All right, so now we're gonna go over how to choose the correct tool for each of the operations. Sometimes one operation can be done with two different tools. You will be able to choose, but what I want to is that you choose the best one for the process that you're gonna follow, right? Okay, so let's say that we're gonna get a piece that we're gonna face, right? So let's get a piece here that we're gonna face. So the first thing for sure is actually to secure it on the device. I'm not gonna go over that because that's a different video, right? But we're talking about facing, right? So when we're facing, we have two tools that we can use for facing, right? One will be the flywheel or facing tool, which doesn't require a holder because it's already had the threaded end there, so it can go inside of the quill, right? Or we could use an end mill, right, with a collet. So whenever we're using an end mill, we have to use the correct collet, right? And again, the end mill does not go with the chuck, right? It has to be with a collet, right? Okay, so you use the end mill with the collet, and then we would be able to actually do the facing process, right? Okay, so when we're facing, we can use the flywheel or facing tool and also an end mill, right? Okay, all right, but I already said that we use the best one for the process, right? Because every time that we have to replace tools on the machine, it takes time, right? And time, it's a valuable resource, right? So for example, imagine we want to face this surface, and then the other process that we're going to do later will be actually cutting this channel, right? So we can sure use the end mill to actually face, or the flywheel or facing tool to face, and then we can remove it, and then we can choose the end mill, and then use the collet, and then do the milling there, right? However, that's too many processes, like replacing the tool. So I would just try, one of the options would be replace just using an end mill and actually facing with the end mill, and then I already use the same end mill to actually cut the channel, right? All right, so now we already talking about using the end mill. So the other option would be which end mill to use, right? So could we use this end mill here? No, right? Because it's actually bigger than our slot there that we're creating, right? So we would check what's the dimension that we want this space to be, right? And then let's say, what's the dimension here that we have? I'm gonna make a caliper, turn it on, close, 0, all right. I'm talking about this side, so I'm gonna go open here. So this is 0.55, right? So 0.55, I would have to choose something that's smaller than 0.55, right? So I would have several options here. So let's see if we can go through and show. See, we have the 3/16, a quarter, 5/16, 3/8, 7/16, half, 9/16, 5/8, 11/16, and 3/4, right? So we can use the biggest end mill that would actually be smaller than the gap that we're cutting, right? So we can take a cut, then we can move a little bit to the side and take another cut on that side, right? Or we can take a cut on the center, move this way, cut on that side, move that way, and cut the other side, right? Would actually leave like some cleaner edges, right? But why would I choose half over a quarter? Or let's say a quarter is actually easy to tell, like why. I would say over a smaller one. So this one would also take 2 passes to do the 0.55, right? But like, why would I choose a bigger one rather than a smaller one? For the smaller one, it's more likely that as we cut, because of the forces, that we're gonna have more bending or bouncing, right? The bigger diameter would actually be more rigid, right? So I would choose whatever is my biggest diameter that would fit in there and take the 2 passes. All right? Okay, so that's how we're gonna choose when we're gonna go facing and then when we're cutting the slot, right? So what if we look at on this side? So see, we have a face, we have a slot, and then we have a side mill here, right? For the side mill, if we're only doing side milling, let's say we are adjusting this dimension, right? And we're gonna use the side milling to actually make this to like 1.95, let's say. Why would I choose a 3/4 other than a 3/8, right? Again, it's the same explanation, right? The 3/4, it's a lot more rigid and less prone to actually have some deflection as it cuts, right? So whenever I'm doing just side milling for adjusting, then I'll go with the biggest one, right? But we always have to look at what's all the operations that we have to do, because if first we're gonna adjust the dimension here and then cut the groove. So then I would have to use again whatever is my biggest end mill that will fit in the groove first, and then I will use the same one for side milling, right? Just so we don't have to remove and switch tools, right? Okay. What's the problem with using an end mill to face compared to the flywheel? The flywheel can cut like a larger area in one pass, right? While the end mill, we're gonna have to take a few passes so we're able to cut the whole surface, right? So sometimes it makes sense, if the area is large, it makes sense to actually use this one to take the pass and then switch tools. But like you'd have to understand how much facing you have to do, so you choose which is the best option as of process, right? All right, so now we went through what's facing and side milling, right? So now we're gonna go over drilling, right? So for drilling, we have a few tools, right? Drilling, we have the edge finder that we're gonna install in the chuck, right? And then edge finder, it's gonna help you finding the edge so you can zero your DRO. And then now you can take this out and go in with your tool that are gonna put the first divot there, so you know where your hole is gonna go. And then you're gonna go with your drill bit, right? So all these tools, the edge finder, the countersink, and the twist drill, they're all gonna go with the chuck, right? So you don't have to, so it's easy to replace it, to change between them, right? You just have the same holder, okay? So which countersink we should use? I usually look for the countersink that's actually the less used one, right? Because the first thing that we're gonna do is, after we know the exact position for the hole, I wanna just come with the countersink and just go tick, just to make a little pointy there, right? So then when you come with a drill bit, when you come with a drill bit and you're gonna push to drill a hole, your drill bit's not gonna travel around before making the hole. So when the drill bit comes in here, it's just go right on where the countersunk hit, and then like now it's gonna be where your hole is gonna go, right? So we're always gonna want to do like a little positioning with the countersink before we actually drill any holes, right? Okay, now we go into drilling holes, right? So in drilling holes, we have another understanding that we have to do. So whenever our hole, let's say we have a 1/2 inch hole to make. So if we look at this drill bit, we can understand that there is a cutting edge on this side, and there's a cutting edge on that side, right? So I'm gonna mark them down. So there's a cutting edge there, and there's a cutting edge there, right? But see that in the center, there's also this little part that's called a chisel tip. So the chisel tip doesn't have any cutting edges, right? So whenever you're using a larger twist drill, you're always gonna need to have a pilot hole that's actually bigger, that has a bigger diameter than your chisel tip there, right? So then you're gonna choose something there that actually would be able to actually make the hole, so you can go with your tool there. And that's not accounting for how much material you were removing, right? Because sometimes you also want to look for that depending on how hard the material is that you were cutting. All right, so now we went through how to choose between the flywheel or facing tool and the end mills for the various operations. And now we understood how we have to go, what's the sequence between using the edge finder, the countersink, and the sequence of using the twist drills. All right, thank you.